So just a quick recap of direct variation. It occurs when the dependent variable varies by the same factor as the independent variable. So if you have, 1 corresponds to 3, then 2 is going to correspond to 6, and 3 is going to correspond to 9. It goes up by the same factor. Here's what I would like you to have down there. Direct variation. Direct variation can be defined algebraically as y over x equals k, or y equals kx, where k is what? Is the, what's our math word for that?
The unknown.
Oh,
The constant to the variable?
The constant of variation. So that's a bit of an interesting phrase. Variation means changes, right? And constant means always the same. So it seems like opposite words. But what it's saying is that, yeah, it's going to change, but it's always going to change by the same factor. Make sense?
Yeah.
It's not going to change somewhere along the x-axis. You're multiplying by 1, 1, 1, 1, 1, and then all of a sudden you're going to get multiplying by 2. That's not going to happen. Okay? It's not going to curve on you. It's always going to be constant. It's going to change, but it's going to change at a constant rate. Okay? That's kind of what that means. Then the last thing we can say is the graph of a direct variation. This is what you would have discovered through your practice problems. The graph of a direct variation is a straight line. And what else is true about it?
Linear?
So linear means straight line, yep. That passes through
The axis.
The dots. The points.
the origin. Passes through the origin, which is at 0, 0 on your grid. Okay? We're going to draw just a little sketch of that. So this is just a blank example, a general example where we have the y-axis and the x-axis. And here's an example of the graph of a direct variation. And the equation of this graph, the equation of this line, is y equals kx.
wait, is k the number that we're putting in times what number?
Correct. K is the constant of variation, which we have up here.
Okay, I get it.
Okay?